Good morning, hello, welcome everybody. To take this opportunity to welcome those who are joining us remotely, those logging in online. Thank you very much, all of you, for being with us today for this roundtable session devoted to the impact of AI on coding. AI is, or shortly will be capable of creating, modifying code. AI is opening up numerous and unprecedented possibilities. Nonetheless, the question arises, is it really revolutionary? Does it constitute a revolution? Very many of you here in the room with this are familiar with coding, and automation in coding is not a new thing. So we want to drill down a bit today into what AI and generative AI actually brings to coding, what it brings new. We have two speakers joining us this morning. We have Eric Foyer. Eric. Hello. Eric, you're the co-founder and CEO of GitGuardian. Also with Michael Tollett. Michael, good morning.
Thanks for being with us. You are head of team European Cybercrime Center at EC3. You'll explain what it is in a couple of minutes. So thank you for being with us today. Avant qu'on commence and before you start, could you please give us a quick introduction of your organization? Let's start with you, Michael, please.
That's a tricky question because a quick overview will take me quite a while. But let's say within Europol, there's the European Cybercrime Center, which of course supports the member state in the fight against cybercrime. Within EC3, there are three departments. One is more concerned with expertise and stakeholder management, so basically building partner relationships. Then there is the digital support unit, which, as the word says, they are in support of the operations and in support of other departments within Europol. And then there is the department which I'm part of, which is the European, the operations department of the European Cybercrime Center. In there are four teams. One deals with dark web, one deals with payment fraud, one deals with child sexual abuse material, and one deals with, I sometimes disrespectfully call it real cybercrime, so cyber-dependent crime, cyber attacks, and that's my team, AP Cyborg. So I think for a brief introduction, I will leave it at that. I can go into more detail if you have any questions, but yeah.
Thank you. Eric.
Donc Eric Fourier, moi je vais le faire dans.
Hello, I'm Eric. I'm going to talk French. Maybe I'll speak a little bit English but it is a bit easier for me to speak French. I'm the founder of GitGuardian. I'm an engineer by training, with a focus on artificial intelligence. I founded GitGuardian about 6 years ago now. It's a code securing solution, specializing in secret detection. We kind of pioneers in that field, in fact. What is a secret? Well, it's a secret. It's an API, an access to a database, a username which is used to connect systems amongst themselves. So we're pretty well known for being able to detect secrets within code and within other tools as well, such as internal messaging systems, like Slack, Teams, stuff like that. And we've spread it out into slightly other areas of code security too now. So we're looking at fintech and analysis, securing ASCode infrastructure. There's 140 of us working with the company, 120 employees in France, 20 based in USA, and we've got customers all over the world, particularly a lot of our client bases in the US, but we have customers in Asia, South America too, and we're also pretty well known for we have the world's most installed application on GitHub, with millions of developers using that free tool. And we also have some really big clients as well as small developers. We work with some of the biggest companies in the world. Thank you very much for that introduction. Before I start, just remind you that we have a little bit of time at the end for questions. We've got microphones here, so we've got an hour. We'll leave a bit of time for Q&A at the end. The microphones are here. Don't worry, we will get round to that at the end of our discussion. So as I said very briefly in my introduction, we're talking about is AI revolutionary? The first question, which is for you, Eric, is the term revolution. We're talking about AI. You're already smiling. Generative AI, does it really constitute a revolution, or is that exaggerating a little bit? Are we really just talking about more automation? I think there are multiple possible answers to that question, but I mean, I think the uses of it speak for themselves. I think OpenAI has just announced that they've gone from like 2 billion turnover to 2 million users and 2 billion in turnover. So I think we've already it's exploding very rapidly. So these new companies springing up all the time, new AI models. I don't know. I'm sure everyone's had a go at ChatGPT. I'm sure everyone in the room's tried that. As developers, we're living in that same paradigm too. Everybody is trying to get into the AI market, and I think we really are right on that crest of the wave right now with widespread adoption of AI. The real revolution in terms of the technology, because in my business we focus on code security. And the way AI has been applicable to code, for generating code, ensuring code quality and code security, I'd say the quality of generative AI is. There used to be heuristic-based motors, which needed to be customized for each language. But now we've got hundreds of computing languages, hundreds of coding languages, see more and more every day. I think that's the real technological resolution of AI, is that capacity by training a model using, the majority of models are getting trained using the same data sets, using the whole GitHub and all that open source stuff, which is publicly available. Everyone's doing more or less the same thing, starting from the same basis. Maybe Microsoft is training their models using it on their customers' client code. I can't say that for sure. That's a bit of a rumor. They'll have to answer that one. But I think the real revolution it's about not having to re-implement the rules every time. It's about the speed with which we can work now with these tools, yielding results which are pretty comprehensive. And also the fact that we now have the same interface. That's what the real revolution is not the technology, it's more the usage. We're now capable of doing things which are much more generally applicable, and we don't have to do it a lot faster. But I'll talk about this a little bit later. There's a weak which is it's the stochastic nature of the model. I've been asked this question, so if I ask the same question several times, I won't necessarily get the same answer. So that's a real challenge for a lot of IT systems. Yeah, okay, that we can come back to later. You started explaining this a little bit, but what's the difference in your field of expertise? What's the difference between current large language models and previous models of automation? We've already had for a while now these systems which allowed for automatic generation of code and automatic code testing, checking breaches, etc. What have large language models actually added to what you already had in terms of automation capacities? Well, I think look today at what's happening now. I think the real contribution made by large language models is prompt engineering. And it's the personalization, the customization of context. And that means that really it's much easier now to customize your motor. For example, when we're talking in terms of security, you can customize it for very precise purposes. But still there's still a lot of limitations and obstacles associated with large language models. The first being that it's the speed and the cost involved. With using an API, they use APIs, so they're proprietary models, OpenAI and Anthropic, they're Mistral by Ginface. The costs associated are much higher, and the inference time is much higher than it is with the classic models, which are usually rule-based and heuristic. And that, of course, that limits the usage potential, particularly when you're working with large code bases. But there is an advantage, on the other hand, the advantage of being able to handle a lot more problems and make it a lot more personalizable.
When you speak about AI, what is the state of the threat today?
Well, that is not that hard, not that easy to quantify. And maybe giving my input as well on the previous the previous question on whether or not it's an revolutionary thing. I think some aspects are indeed revolutionary, but in terms of impact on cybercrime, we don't really see that yet. Now, of course, we can go a little broader than just code generation, because if you talk about code generation specifically, then we would need to see proof of LLMs being used, for example, to write malware. And we can assume this is the case because, like, the entire world is using LLMs right now. So why would cyber criminals not experiment with this technology? They have been historically very good at like leveraging new technology, not only cyber criminals but criminals at large. If we go back, I don't know, a couple decades or even longer, for example, when machine guns were invented, the criminals were the first to use this, while the cops were still using older type of weapons. So criminals will use new technology as soon as it appears. They don't have the same hurdles that we do in terms of legal framework and data privacy issues. So for sure, we can assume that it is being used out there. Have we seen the empirical evidence yet? Not so much. Now, if we look a little bit wider than just code generation, and for example, we look at like writing a perfect phishing mail or a spear phishing campaign, for sure, now these tools make it possible to do that way more professionally in many more different languages. So, for example, historically, the Japanese audience was fairly safe from phishing because it's like, well, who speaks Japanese except for the Japanese people? Well, I know a few words, by the way, but anyway. But now this audience as well can easily become the target of a phishing campaign because these LLMs can assist you in crafting good campaigns in any language. So it's a matter of also a matter of like raising the level a little bit of the cyber criminals and facilitating. Just like in code generation, it makes it much easier. It's a scale issue. So now they can target a wider audience more efficiently. Again, in code generation specifically, yes, I'm willing to bet it is being used. Have we seen the evidence yet? Not really, as far as I know. Of course, this will only last until we see some infrastructure or like do a house search, seize a computer and see that this guy has indeed been using these tools. Now, what we also know is that some of these dark LLMs, and I believe this is actually the title of one, are out there. So this is also being marketed as a thing because we are probably going to talk about this further after this.
Oui.
But yeah, exactly. So there are guardrails in like the ChatGPTs of the world, but then there are LLMs without such limitations that are specifically marketed towards criminal use, such as the dark LLM, such as WormGPT. There was a project or a service a while back. So yes, the criminals are definitely heading in that direction. But then coming back to the revolutionary part, is that a game changer for us? Not necessarily, because we were already dealing with advanced malware. So it's more of a scale issue than rather like revolutionizing what we are encountering.
Eric, est-ce que de votre côté, vous avez déjà observé ou peut-être
have you seen in your business, perhaps from your clients, have you had comments from clients saying, oh, we've observed, we've had attacks on our code, they're perhaps making use of AI tools? Have you had that kind of discussion? Michael says that there's not yet any real hard evidence of people using AI tools to generate code for malicious purposes. Have you had any feedback from customers or partners which would indicate that's the case? Yes, I think I actually agree with Michael very strongly. It's really difficult to know for sure if malware is being created by a human or by an AI program. Whether it's for using AI to produce malware, to generate malicious code, to create new security rules for code. We're still at a stage right now where AI is still kind of in the pilot phase. It's not capable of working independently yet. It's a tool for use by developers. It's not independent. And if you look at the number of products that are on the market, GitHub Copilot, for example, everybody is marketing its AI product as a copilot. It's not independent. We haven't yet reached a stage where AI is completely autonomous, which is, frankly, quite reassuring. Not yet, Eric. No, not yet. So I'd say no, we're not yet at that stage. I've had no particular feedback from customers saying that, and I think technically we're really not capable yet of identifying, for the time being, whether a code's been generated by an AI or not. There's research being done in the imaging sector, different image generating algorithms. They're trying to do pixel fingerprinting. Perhaps we should do that with code to make it clear that code's been generated by AI rather than human.
With AI being, just like you said, Eric, a good co-pilot, developers might be less watchful. How can we be sure that they remain vigilant, Michael and Eric?
Well, I think what Eric said is true. They are a co-pilot, and they should be treated as such. They are, in my understanding and in my experience, they are fulfilling now almost the role of a junior developer. Well, it's both things. They are AI in general. It's like it speeds up things, and it raises your level a little bit. So it acts both as, I would say, a personal assistant, a junior developer if you talk in code context, but also as like a coach, somebody that's a little better than you, and you can ask questions, and you can maybe, if you encounter some errors in your code, you can copy paste it in there, ask for some guidance. So it's both of those things. But still, and I was attending another panel yesterday on responsible AI. I mean, the human is still responsible for the code that is being generated. So it's a co-development almost. It's a junior developer that you have at your disposal, maybe even a couple of them. But you are the architect of the code. You are like the one that needs to ideally understand what code is being generated and what it does. So you have the final say. And I think actually, going forward in like education, this will become also a more prominent role and this is like goes for generative AI in general. You are no longer the generator, but you are the curator in some sense of what is being written. So I think the junior developer role is a little bit threatened, and I think in education they will need to start teaching some skills that are on a more senior level from the get-go, because the development you had starting, and again, I'm a budding developer. I've never really had like a real developer job, but I do write some Python and whatever, and I write it way better now with AI. So I think in education, the normal trajectory you had of becoming like a junior developer, and then over time gaining more experience, and then learning more about actually architecture of a project and the code. Now you will need to fulfill that role much earlier in your career, I think, if you want to be successful. So they will need to acquire some skills in that sense to properly secure the code, to have an overview of the architecture. So, but again, the simple answer is, as a developer, you're responsible of the code you're pushing out into the world, so you should remain vigilant, and you should make an effort to understand everything that is being written for you by the AI, because that is, of course, the threat that you're facing is, let's say, a budding developer or somebody like me would previously would probably not create a full stack project and upload like a full website with a database backend and whatever. Now I feel more confident in doing so, but let's say I have AI write an authentication module for me. Oh, sorry. That sounds way louder. Let's assume that I have the AI write an authentication module for me. If I don't fully understand, then there might be some bugs in there, because again, the AI is using previous code it was trained on, and it is implementing that. But it's possible that it's making mistakes. It does make mistakes. So if you, as a developer, are not confident enough to spot those mistakes or to properly test the code, and whatever you push it out in the world, feeling a little more confident in your skills because you have this personal assistant, then that is indeed a risk that you should be aware of. But on the other hand, again, talking from my budding developer experience, usually code testing was just manual review, and if you have a bug, then you try to debug manually, you put a breakpoint on it, whatever. Now, these tools also offer you more robust ways of reviewing your code, of like automatically testing your code and whatever. So they also assist in that part of things if you're like careful enough and make the effort to do those checks.
Eric, je répète la question. Comment est-ce qu'on peut s'assurer que dans ce...
Eric, I'm going to ask the same question to you. how do we keep up the necessary level of vigilance when using more AI tools? Well, it is a very good question. Even if you're talking about the training of those large language models, I was talking about this earlier. These LLMs, they trade on a public code base which contains vulnerable code. It contains malware. And, IA is not necessarily discerning. By definition, those models, they're biased towards the median and the average. So you have that impression that your Copilot may be, it might be like a junior development, but you've got to be careful with the potential risk of surrendering too much power to ChatGPT or whatever AI tool you're using and letting the Copilot fly the plane without checking what he's doing. And we can understand why it's more of a philosophical reflection on us as humans, isn't it, of the tendency towards being lazy and letting the memnotechnic do things for you. But I think one of the main challenges for young developers these days is to not rely on the Copilot too much, to not assume that AI is always right, to challenge the Copilot. And that's a serious problem, because even in the marketing surrounding AI models, when I think it's talked about as a Copilot, it's talked about as an assistant. You can imagine that perhaps the Copilot is being given the senior role, it's becoming a senior partner. It's not infallible. And that is, I think, one of the most important risks that we face and the biggest dangers with AI. It's about a question. It's really about educating developers. It's more about education than tools. And that's not what transpires from the marketing of the AI tools. Eric, I'd like to hear you talk a little bit about what Michael already mentioned about the potential evolution of the role of developers. I'm sure we've got a few developers with us in the room today. Michael said he thinks that in the future, it's kind of going to be creaming people off a little bit. You're going to have AI-generated code. We talked about GitHub earlier. There's plenty of code out there which people can use. And there's potentially a risk, in fact, on the sources of code, but that's another question. But how do you, as organizations, is it in everybody's best interest to accompany this change? Is no point fighting back against technology, but do you think that the developers will be sort of curators of code in the future? They're going to be curators rather than creators. Do you think that's the future of development? Well, it's interesting because if you just not just AI, looking a bit further afield than AI, taking a step back, but it's one of the reasons that I founded Git Guardian back then, because I think the role of developers in recent years, we're asking with DevOps evolution, DevSycOps evolution, developers now, they're expected to know to do back-end and front-end, front-end, infrastructure, and to know all about security. And that's why we founded Git Guardian. You can't be an expert in everything all the time. So we need to create tools which allow us to automate a part of that work. And tools which can be used for educational purposes as well. So I'm deeply convinced that it's not going to replace human experts. There's always going to be a value to be an expert developer, to have an expert in a certain database, an expert in a certain mobile application or a web application. But I think the real interest, the real benefit of AI is it allows us to educate and to allow us to get a grip on a domain where we're not necessarily experts. That's my personal takeaway from recent developments anyway, is that AI is not replacing human expertise. It just helps us to better understand adjacent domains where we're not potentially experts in. But that's a big challenge for developers these days. We're operating in a world where there are fewer and fewer gates in the development process, and we're expected to understand everything about the deployment of the code from design right up to implementation and observability. And AI, I said, it doesn't replace human expertise, but it provides a useful tool. But of course, that doesn't prevent. It still doesn't absolve us of the responsibility of challenging our co-pilots and questioning the AI. Oh, okay, Eric, another question for you. How do we incorporate AI into a process, we've mentioned this several times, which is already automated? For example, a developer is capable already of working with automation tools. How can you intelligently implement, if you want, artificial intelligence? You talked a little bit about DevOps and PsyCops. How can generative AI be an additional tool in the arsenal of the developers working on that chain? Very good question. I could give you an example, perhaps, of code security, because that's my domain of expertise. With Git Guardian, I think for us, OpenAI, when it came out, the question we asked us, the same question that a lot of startups asked themselves was, ultimately, with an OpenAI prompt, could that replace 3 or 4 years of our R&D efforts? So obviously, we're scared. We spent a bit of time doing testing. We're French, we're scientists, so let's try it. And we put in a prompt to OpenAI and asking them to secret. I wanted to know if they could do better than our own model, our own engine. If the answer was yes, then it was going to be difficult for us to keep the company running. But no, objectively, we know that we wanted to go and challenge the detective capacity of the AI. I did a couple of blog posts about it. The results show that, in fact, there are three key problems with the large language model. The first is the cost. So to give you an example, we scan all public code in real time. The cost of doing that with an OpenAI, even a GPT Cap Turbo, which is the latest optimal model, is $200,000 a day. So there's a first barrier to entry. The costs are high. Then there's the inference time. And that's a real problem. These models are pretty slow. And the third big issue, fortunately, as I say, our model was more precise in detecting secrets and what it's trained to do. But the third problem, which I think is quite a fundamental problem with AI models, is the stochastic architecture. It's very difficult for an IS system to take on board the fact that I'm going to give an input 1 and I expect an outcome. If one time I do that, I get one answer, and if I ask the same query, rerun that same query, I'll get a different answer. Even though, you can get around that problem in some way with models, but that stochastic, non-deterministic nature of the model is a real challenge for information systems. So I think what we've taken away from the research we've done into OpenAI models so far is that we really believe in the importance of a hybrid detection strategy. Do we want rapid detection of threats, deterministic, and using AI once you've detected a problem, on the other hand? For example, we're detecting secrets. We're looking for secrets in codes. If you extrapolate that to broader code security, well, if you're detecting a vulnerability in a code somewhere or anywhere else in cybersecurity, if you're detecting an attack or weakness, once you've detected the problem, whatever the problem is, there where AI becomes useful, it's the speed with which it can work to solve it. If I've detected a problem and I have deterministic rules, it makes it much easier to understand and define what you're looking to detect and what you're looking to resolve. How then, when I've detected a code, how can I rapidly resolve that code? That's where AI becomes useful. So it's an approach which, again, it's the essence of these models, which is based on a context which you understand. What AI models do is summarize information and provide advice, but we can't let the models, the current capacity of these models, they can't be trusted to take decisions. They are tools to assist with resolving problems.
AI growing in for example, in coding, for example, is it safe to assume that we are crafting a more dangerous world? I mean, with AI being developing is by itself, we can assume it will arrive in a couple of months, a couple of years already. Are we making by ourselves a more dangerous world?
I don't think so. I'm an optimistic person. I see mostly a lot of benefits, a lot of opportunities in use of AI. Of course, there are risks, and it's why legal frameworks are being defined. There's the AI Act. So, of course, there are threats. There will be misuses of this technology. And then looking a step ahead, now we are still in the phase where they are assisting us. Once we go towards more autonomous agents, and I'm not talking about general AI, that's, I think, a long ways off. But still systems that are a bit more autonomous from just being personal assistants. There are risks associated with that, but specifically reflecting to the cybercrime, I don't see that as an existential threat, let's say, because the only thing it is doing, it's making the actors a little bit more, well, a lot more efficient, I would say, in terms of speed of development. It's making them a little bit more savvy. As Eric said, they things that they weren't previously, they maybe not that strong in, like, I don't know, obfuscating their code or whatever, or implementing some modules that make the code harder to detect. So yeah, it's upping the game a little bit in that sense, but there were already like world-class advanced threat actors out there. So in that sense, I don't see it as an immediate, very large threat. So I mostly see the opportunities. Again, also from our point of view as an agency, I think we have a big data problem in a sense that we have a lot of interesting data sets and just not enough manpower to exploit those data sets. So also from our side, I see a lot of opportunities there. Again, checks and balances, of course, and this is what makes us more or less efficient than threat actors, because they can just employ whatever they want, whatever new technology they find. They just run it without any concerns for legal frameworks, clearly, because they are already breaking laws, so who cares about one more? But from our side, before we start implementing these things, so in the agency we are exploring this for sure, but we have recently appointed, for example, a chief AI officer, there's an alignment committee on AI, so there's a lot of things that go into checking like the balance of things, the data privacy issues, before we start implementing these things, and even before we start using it in our own code generation. Although there I see some quick wins, because as we previously said, the developer is responsible for his code, so we can use it as a coding assistant without directly using the AI on operational data. It's as if it just speeds up a little bit of our own code generation, and then we can use those scripts, of course, on operational data. So in code generation, I see more of a quick win from, let's say, the good guy side of things, but it's a different discussion of using AI at large, code generation and other, on directly on the operational data, because there we're not as free as, I'm not even going to say as we would like to be, but as like the opponents are, let's say.
Eric, est-ce qu'il y a une...
Eric, you've said it earlier on, but I'm going to ask the question once again for more details. What are the advantages between large models with plenty of functions and requirements, and then smaller models? Even if we have a look today at many companies, it seems that many companies look at smaller models. In terms of coding, what's the most beneficial in order to draw all the advantages that you are mentioning, both of you? A big model or a small model, well set with the right data? I think it depends on the different use cases. First of all, I wouldn't call it a small model, but an open source model versus LLMs that are available through APIs with proprietary models. There's a confidentiality of data. And I would say that it's the first advantage, really significant. Do I go for rolling out an open source LLM in my cloud, in my infrastructure, or do I accept sending my data, OpenAI, Microsoft, any provider of a large model? So that's the first decision to make in terms of our tree structure and the decisions to make. That's the first question that you need to ask yourself. And second, and that's what I was saying earlier, it has to do with the cost. The smaller the model, the easier to train. It costs less to fine-tune, and it's faster. So that's the first element of choice. And it gives you that capacity of an easier fine-tuning of a small model on a specific case. And that's something that we do. We have clients who have very high security constraints, financial or medical ones, and they are totally against sending their data either in our cloud or even in the outside. And there, the use case of a small model rolled out in their cloud, in their infrastructure, is really meaningful. And that's the evolution that I see. Then in terms of pure performance, you have ongoing benchmarks. And they are very interesting to check the open source models and the major models. And the benchmark is clear. GPT-4, for the time being, still beats all open source models. And then it remains a trade-off between cost and performance, data confidentiality versus sending data. Our philosophy in terms of products and machine learning at Git Guardian is to go for the advantage of using open source models that are fine-tuned due to the confidentiality of data, and also to have a level of defense that is strong. And if we step back on that part, the challenge today for companies that are willing to create these models and bring added value to use cases, for example, or use case, securing codes, it means that we have a training database or data set that is stronger than the competitors, of a better quality, and that will allow to fine-tune these models, or even better, to have a comprehensive training. And that depends on the resources and the number of GPUs that you have. These are the two solutions. Do we go for a total retraining or fine-tuning of models? Eric, isn't the question really a question of control that you want to have on AI? Do you have a stronger control on the model that you have fine-tuned? Or do we accept to let go a part of the control when you use major models, cloud, Gemini very soon, and others? Yes and no. There is a control in the data that we provide for training, and then there is a second layer of control that we can apply. And if we look at ChatGPT, it's a huge prompt on top of GPT-4 model, and there is a second level of control there that takes place at the engineering prompt. And we've seen recently many attacks on all of these assistants. How can we start AI queries and understand what's the initial prompt and the components of the model? Indeed, it is easier to better control the model when it's your own, but especially when you own the training data set. I think it's the first component. But then, clearly, these models are generative, so there is a stochastic part that belongs to the way they are trained, the way they are structured, and there we can't escape that. It's part of the definition of these hard language models and generative AI. What are the weaknesses of these models? Because they are not perfect. They probably have components that we need to improve if we want to make it work.
Those large language model when it comes to coding. Michael and Eric.
Well, let me give the generic, non-very technical answer, but it's that many people don't realize that these LLMs are recalculating a probable answer. So they are great at formulating something that sounds extremely believable, but isn't necessarily true. And this is, again, I don't know how technical the entire audience is, but this is something let's say, society at large does not really understand, because they think it's like a Google. It's looking into a huge database and giving you a right answer. And that is not the case. It's recalculating a probable answer. So, and that's, I think, a weakness or a feature of all of these LLMs that you need to be aware of. And if you're aware of this, then you treat it in a different way. Then you are a little bit more cautious of just accepting it as truth. And then it becomes a tool that, again, in code generation, you will still need to check whether it's doing what you intended it to do. So that is, for me, the biggest weakness. And again, it's inherent in the technology. coming back again to what was previously talked about, like explainability, of course, is also a big thing. And what you're seeing now, or some projects are now linking, for example, the LLMs with like a graph database, a graph knowledge database on which it builds, or from which it gets the knowledge. And then you get more explainability on the answer that is produced. So it shows you how it came up with the answer. And that kind of helps in making sure that the answer is actually truthful. And for sure, for us as an organization, that's also quite important to be able to have this explainability on what is being done in the black box for most applications that we would be interested in using it for.
Eric?
I think it's a good summary, but to add something on the technical part, and that's a little bit what I said earlier on, there are strong limitations in terms of cost and speed. These models need to turn on GPUs. I think you have all seen the capacity of NVIDIA. It's over 2 trillions, and I think they have a GPU at $40,000. It's a bit like a Rolex watch. You need to be on a waiting list if you are a company. And then there is a secondary black market of GPUs. And it's a limit which is pretty strong in terms of orchestration. When you roll out a model on a GPU, I wouldn't say that it's complicated, but it's the biggest part of today's work clouds that operate on the GPU, so this is an additional constraint for self-hosted deployment. And here I'm talking about open source models that are available. And then, of course, I think we have a good summary of the likelihood of models and the stochastic probability of answers that can vary through time. These models are trained on knowledge bases, and knowledge is deeply dynamic. I think it's interesting to repeat that. In Google, you have an algorithm that changes in time, while GPT-4 is trained on snapshots. Every 3 months, they will retrain the model according to the knowledge. I think that research progresses and will have incremental progresses in the end. But that's a limit that we face and that is strong. And we've seen that at the beginning of the emergence of OpenAI, the model only had access to the knowledge before 2021. So that users can sometimes not understand that the model has not access to knowledge in real time. So we'll keep a few minutes for questions and answers at the end. But I'd like to come back on autonomous AI that we mentioned at the beginning of the discussion. How can a totally autonomous AI transform, on the one hand, development on the whole chain, and how can it impact the role of the developer?
Autonomous AI will transform the software process, and how will it affect the developers?
Well, depends on how you will define fully autonomous, right? What we are seeing now is that people on top of these LLM models are building like independent agents. So they don't just give you an answer of what you're asking, but they do like a step-by-step process of how they could achieve this, and then for each step they do like an iterative prompt of to get there and to take actual actions, which could be like ordering a pizza and paying for it online. It could also be like developing a full software tool by first defining, let's say, the individual parts that need to be done, and then setting up the infrastructure and whatever. So I believe there are some experiments already in this sphere. We're not there yet. From let's say a cybercrime point of view, I think it will be interesting for sure to have. For example, could be like fraud chatbots out there that are just autonomously scanning LinkedIn, finding an interesting profile, then sending them like a phishing mail, maybe getting them a link to an investment page that was created by the AI, could even be like created tailored to this specific target. Then they on this page there could be a chatbot, and then they go into a conversation and they do some investment fraud kind of things. So having this in like a solution in a box is of course sounds like a great cyber criminal product to market. So there are definitely some new challenges there and some criminal opportunities, but we are not there yet. Other things I could see, again, and I'm veering a little bit away from the code generation, but for sure there's a larger potential impact. A call center in a box, for example. Now we have people that are actually calling real people in a call center somewhere in an unfriendly jurisdiction and getting scammed. Again, this could be like an in-the-box solution and in a sense an autonomous agent. And again, it largely depends on how you define it. If you're really talking like general AI, I think we're a long way off. And this is like my layman interpretation of this. But yeah.
Eric.
Indeed, I share Michael's opinion. I think we're not there yet on autonomous developers who can code. I think the best proof of it is already the wage of developers that still remains very high and is still uncommon on the market. That shows that developers will not be replaced by AI so soon. Then I think we can believe that no company nowadays is ready to create a purely AI developers team who are going to code softwares and roll it out in production. I don't think we're there yet. And it's even interesting, all projects of autonomous dev AI are still programmed by humans, and for the time being you have a set of prompts and traditional interactions. They do very interesting things, and I believe that plenty of things are going to happen in the next years, but according to me we're not there yet.
Michael, how is your agency adapting to this new context, so new threat, AI coding capabilities, cyber criminals using AI to create fake phishing campaigns, using AI for taking the voice of someone else. How are you adapting to this new context?
Well, I think, as hinted on previously before, as I mentioned, I don't think it's like a game changer. So whether or not they're doing it manually with a guy behind the keyboard doing these things, scamming people, setting up websites, or it's like an automated solution, it's a matter of scale rather than a difference in really approach on a technical level. So, but of course, AI is having a huge impact on our organization in general, like not only looking at the threats, but definitely looking at the opportunities. So as I said before, we are exploring a lot of opportunities we have. So it's a big thing, of course, for all organizations, Europol included. So it's a big thing for us to explore what is possible. On the threat mitigation, the most important thing for us is to be aware of what is out there. So of course we have a cyber intelligence team. There's OSINT. There's of course private partners that inform us on what is out there, and then we'll see like case by case if we encounter this out in the wild. But fundamentally, it's not a game changer. So again, whether they're doing something manually or deploying an autonomous agent, the traces we go after are still the same. They are using some infrastructure. There are some guys behind the keyboard. They are using some identifiers, some IP addresses, some email addresses. They have some accounts somewhere. So the identifiers we go for and we pivot on and we run our investigations on stay the same. Crypto transactions, same thing. Whether or not it's like an auto mixer that does this or it's a person leveraging this, we still can employ the same strategies we have already been employing.
A very last question for you, Eric. If you had 3 pieces of advice to give, because we need to finish with practical recommendations for the audience here who are willing to integrate AI, they are developers, heads of software, or whatever their job, what would you advise them in terms of assistance, in terms of support to AI, so that they get something who could, in turn, be beneficial to the business, because that's what we mean here. I can talk from my experience. Indeed, we have a security code process. I have a team of 60 developers. I have not managed the project myself, but I'm personally very interested in it. We've managed a rollout internally and how we can integrate code tools. And the adoption, and it came as a surprise for me, it was not exponential. It's pretty slow. I think that as all new technologies, there are different curves in the adoption. And general pieces of advice would be first to start with training, education. Developers should have the opportunity to know how to use AI, what added value it can bring to their work. And that's a must-have. If you simply provide a tool and that you tell people, go for it, create an account, here is the portal, it will not work that well. You need to support the change, even if the tool is powerful and has a lot of value. So I would say that first of all, it has to do with training, education, and then have the correct guardrails, especially in terms of data confidentiality. The major issue of these solutions is to know what data we allow to provide to these tools, what about the data propriety, and that's a brand new field of security in general. And maybe the Gartner will find a wonderful name for that, LLM security. They're probably already thinking about that. And the question is how we can make sure that we protect and that we have an LLM firewall in order to filter the data that will be sent to these LLMs that are IPI-based to avoid sending confidential and sensitive data. Questions now from the audience. There is a mic. Okay, we have a question over there. Please put the mic under your mouth so that the people who are listening to us remote can hear your question and translation. I work for a subsidiary of Roche France. I have a question in terms of the use. You talk about co-pilots and about learning. And there is probably a bias in terms of learning the code because the code is also vulnerable, so that the result will not be amazing at the end. What's going to happen in the next generation when the AIs will be at the source of the learning of other AIs? And what's the time frame?
Yeah, I can maybe answer in, let's say, the general sense. I read that there was some experiment on training an LLM on LLM-generated data. So not talking about code specifically, but just text. And I believe it took like 3 generations of like getting total garbage. So basically, you train like the 3rd generation of an LLM trained on only LLM output, it becomes total garbage. So I think it's a very real question, a very large, important question, because more and more AI-generated content will be out there. But for code, actually, now that while I'm answering, I'm thinking about it. For code, I think it's less of an issue because of the fact that there will be this human curation, right? So there will always be a human verifying this code, and code by its definition should work. So if it's not functional, then it shouldn't be out there. While for, let's say, articles that are being generated, like content, you can just have a plugin, post this on your WordPress site, like constantly a new article every day, and without any human intervention. And so this becomes garbage over time. Code, again, with the human check that is being done in there, should be of a little bit higher quality. So maybe this will impact the code less, but long term is definitely an issue, I think.
Thank you. Merci pour cette question. Est-ce qu'il y a une autre...
Thank you for the question. Is there another one? here at the front. Good morning. Elliot, I'm a developer. Welcome. And I have a question. When you have mentioned the current state where AI is a co-pilot for developers, in the future, it's very likely that it will go beyond that. So in terms of cybercrime, I can imagine that it would allow bigger access to the population. So why should we take risks and have a criminal activity while we can create automated softwares with AI? According to you, could it lead to a change in the balance between black and white hats? Could it create an increase of fault detections and more insecurities?
No, I can. I think in terms of the balance, I mean, it's being leveraged by both sides. So I don't think it will change, let's say, the balance of power. I do think, and this is something that we haven't touched upon yet, by having this LLM, you can, of course, run it locally. There is less of exposure, let's say, within the code development cycle of malware. Necessarily like exposure. So before you would have to go to public forums, maybe go on the dark web, talk about what you're doing, maybe get some help, maybe hire somebody to help you, and so you are out there, you're leaving traces. So that becomes interesting from a law enforcement point of view to go after this. If you have more solutions in the box running on your local machine or on your private infrastructure, then these traces become less. So in that sense, it makes things a little bit more difficult from us. Not necessarily an answer to your question, but something we haven't touched upon yet. Then will it become more attractive to become a cyber criminal because of this? I don't think so, because what we already have in cybercrime is it's crime as a service. Like no cyber criminal does the entire chain themselves. They just rent the ransomware, for example. They buy the credentials. They infect the system. So the tools are already out there for cyber criminals to do this with a lot of ease, basically. And that leads us into what makes a person a cyber criminal, and then it's often like I don't want to be too soft about this, but it's indeed a lack of opportunities. For example, this is why we see it in certain parts of the world that it's way more active. They have less opportunities to get a well-paying job in tech, and so they veer a little bit towards cybercrime. And once you're on the drug of cybercrime, the easy money starts rolling in, or what seems to be easy money. Then, of course, you're gone on that track. So from our side, and I also see a possibility there of integrating this a little bit with the LLMs, is also doing some offender prevention when people start taking their first steps towards cybercrime, to make sure that they are at least made aware of the fact that this is not the great career path, and there are other opportunities, and maybe we can veer them towards like a code camp type thing, or like a job opportunity. And this could, in my opinion, be part of the guardrails that are built into these LLMs. So if you ask it to generate some malware or to scan some vulnerabilities or whatever, instead of just getting a message that I cannot do that because malware is bad, maybe it could give some more information on what you could do with the skill set if you are interested in technology.
Merci, Michael.
Thank you, Michael, for that answer. We're unfortunately coming to the end of the roundtable. Thank you. We can give you a round of applause. Thank you for following us. Thank you to all those who are online, and enjoy your lunch if you can find it.